I'm Anil Kumar. Welcome to this video where we'll talk about few questions based on basic mathematics. We'll have about 10 questions in this video. All are multiple choice, and I hope they will help you to review the concepts learned. The question here is, find the range for the solution of this double inequality, which is 7 is less than equal to 2x minus 1, and that is less than equal to x plus 11. 4 choices are given to you. When we talk about range, we have to find maximum and minimum value, right? So basically, when we say range, we mean maximum minus minimum, right? So we have to find upper and lower limits of our solution, and then we get the solution, correct? Now in this double inequality, you observe that x is there only in 2 places, not in the third one, and so it cannot be eliminated. Now when that is a scenario, then you have to solve the inequality in 2 parts. So one part will be that 7 is less than equal to 2x minus 1. The other one will be 2x minus 1 is less than equal to x plus 11, right? And both are performed with AND operation. Both should be true, correct? Now bringing 1 to this side, we get 7 plus 1 is less than equal to 2x. So 8, and we can divide by 2. So we get the value of x, which is 4. So x is greater than equal to 4. On the other hand, we can bring x on this side. So we get 2x minus x is less than equal to 11 plus 1, which is x, which is less than equal to 12. So as you can see here, the solution is, we get the 2 intervals. Okay, let me just make a number line and show it here. Assuming that 0 is somewhere here, okay, let's say this is our 0. We are saying x is greater than 4. So let's say this is 4 for us, right? So we are saying greater than equal to means we include this value, and that is our solution from one side. The other side, we are saying that x is less than equal to 12. So let's say this is somewhere here, we have 12, and we are saying that x is less than equal to 12, correct? So on that side. So clearly, whatever is common between the two is this interval. So our solution is that x has to be greater than equal to 4 and less than equal to 12. So those are our lower and upper bounds, right? So this is the lower bound and that is the upper bound. Now to find the range, we'll do 12 minus 4, which is equal to 8, and so the answer is B. Is that clear to you? That is how we are going to answer this question. So I hope the concept is clear. Now let's take the other questions in this test. Which of the following is simplification of 3 plus 9 minus x square over x square minus 3x? 4 options are given to you. So this involves factoring and simplification. So let us see how to do it. So we have 3 plus 9 minus x square over x square minus 3x. Let's write this as x square minus 9. We can take minus common. So we get 3 minus x square minus 9 over x square minus 3x. Now, we can factor this as a difference of squares. It could be written as x plus 3 times x minus 3, correct? In the denominator, we can factor x out. So we get x times x minus 3. Now x minus 3 is a common factor in numerator and denominator. It can be cancelled. And we can write this as 3 minus, let's put brackets here, x over x plus 3 over x. Is that clear to you, right? Now we get 3 minus x over x is 1 minus 3 over x, correct? And that clearly is 3 minus 1 is 2 minus 3 over x. Is that clear? It's very important to place the brackets, or when you open, make both of them negative, right? then you get the correct option. Otherwise, you may mark the wrong option. 2 minus 3 over x is the right option. So that is how we get our answer. I hope that helps. The question here is, the length and breadth of a rectangular field is in the ratio of 3:4. Now, when you say that, it means what? Let's say that's a rectangular field. Ratio of 3:4 means it could be 3x and 4x, correct? So that becomes ratio of 3:4. Now it's given its area is 6912 square centimeters. Find its perimeter. So area, which is length times width, is given to us as 6912, and it should be equal to 3x times 4x, correct? So we have 6912 equals to 12x square, right? So 6912, okay. So we can write this as 6912 divided by 12 equals to x square, or we'll do the square root of this, which is square root of 6912 divided by 12. That is x, correct? 6912, okay. So now we can use calculator to calculate this value. You can also divide by 12 and figure out. So we have 6912 divided by 12, and we'll do, which is 576. Square root is x. Square root of our answer is equal to 24. So we get 24 is the value of x, correct? Now once you get the value of x, you can substitute and find the sides. So we can say length is 4 times 24 and width is 3 times 24, correct? So that is 96 and this is 72. Perimeter will be 2 times length plus width, which is 2 times 96 plus 72, right? So that should be equal to 8 and 7, 16, right? 168. And when you multiply, you get the answer 2 times 8, 16, 1, 12 and 1, 13, 3, 1, 3, 3, 6. So B is the right option for perimeter, correct? So that is how we are going to solve this. So I hope the steps are absolutely clear. The question here is, ABCD is an isosceles trapezium. AB equals to 30, CD equals to 20. AB is parallel to CD, right? E is a point on BC where BE to EC, this ratio, is 2:1. What is area ratio of triangle AED to trapezium ABCD? 4 choices are given to you. You can pause the video, answer, and then look into my suggestions. Now we can find area of the trapezoid. We can write this as area of trapezoid is basically half of sum of parallel sides, right, which is 20 plus 30, times the height. And we really don't know what the height is. So what we are going to do here is we'll do some construction. So let us extend this side and drop a perpendicular like this. So this is a perpendicular and that gives us the height, correct? So let us say that this particular length from the point, let's say P to Q, is x. Rather, we have 2:3, so we'll say let it be 3x, right? That makes sense. So if I assume that PQ, so we are saying let PQ equals to 3x. In that case, since we know that the ratio of BE to EC is 2:1, that is, this ratio is 2:1, these two are similar triangles. So we have the side EQ as equal to 2x and PE equals to x. Does make sense to you, right? So now we have this distance x, that is 2x, 1:2 ratio, total becomes 3x, correct? So that is a small construction which will help us to find the solution of this question. So we'll multiply this by the height of this trapezoid, which is 3x. So that becomes area of trapezoid. Now, we are interested in area of this particular triangle, which is AED. AED means this triangle. Now, what is the area of this triangle? Now, since these two are parallel sides, what we should do is we should take away the area of the other two triangles from trapezoid to find the area of triangle ADE, right? So that should help us. Okay, so that's what we are going to do. So we are saying that the triangle AED, area of this triangle, is equal to area of trapezoid minus area of triangle ABE minus area of triangle DEC. Does make sense to you? Then we get the area of the triangle of our interest. Okay, so that is how we are going to get this area. Now, so this area of trapezoid is half of 50 times 3, right? 20 plus 30 times 3x. That is the area of trapezoid. And from this area, we are going to take away area of these two triangles. Right? Area of triangle is half base into height, right? So we can write this as equal to area of trapezoid is this, which is half of 50 times 3x minus area of A, B and E will be base is this time 30, so half of 30 times height, which is 2x, right? So this height will be 2x minus area of the small triangle, which is half of 20 is the other side length, times x, right? So this side will be x. So that becomes the triangle AD area, right? Which you could simplify. So we have x is common factor, right? So x is common, and then we can simplify this term. So what we get here is 25 times 3 is 75. So we have 75x minus, this is 30x minus, this is 10x. And that is equal to 75 take away 30 is 45, and then we have 35x, correct? On the other hand, area of trapezoid is 75x. This is equal to 50, half is 25, which is 75x, correct? So now we get the ratio of area of triangle. So area of triangle AD over area of trapezoid, let me sketch like this, ABCD is equal to 35x over 75x. So x and x cancel, and you can now divide by 5. So when you divide by 5, we get 7 over 15. So that is the ratio. So the answer is C, 7 over 15. So that is the ratio of the area of triangle to that of trapezoid. So I hope that makes sense. Here we have an excellent question based on partial factoring or decomposition of rational functions. x square over a plus bx whole square is equal to 1 over b square within brackets 1 minus a over bx plus a plus b over bx plus a whole square. So when you have a linear multiple or linear repeated factor, in that case you can always break it up like shown here, right? Since the degree of numerator and denominator is same, so we first divide and get a whole number. Now you can always pause the video, find the value of b. I'll show you a very neat way of doing it without going through long division and standard way of doing it. So let us try to understand what is bx plus a whole square, right? So let me write down here bx plus a whole square is basically equal to b square x square plus 2 abx plus a square, right? So that is the term which we are looking for, which will cancel with bx plus a whole square, right? So that is what we are looking for. Okay, now let us see how to do it. Well, since we already know that we need to write x square over a plus bx whole square as 1 over b square times something, what we can do here as first step is x square over a plus bx whole square can be written as, we can multiply and divide this by b square, right? So we have 1 over b square times b square x square over a plus bx whole square. So that part is absolutely clear. Now the idea is we already have b square x square, correct? We already have this term which is b square x square. We want the rest. So what we can do here is we'll just keep this 1 over b square outside, right? Square bracket. So we come up to this stage. We have here b square x square. We want 2abx plus a square. So we will add 2abx plus a square. And we'll have to subtract also the same term, which is 2abx, and subtract minus a square. Is that clear? So we added and subtracted this term, making this as a perfect square. And in the denominator, we have a plus bx whole square. Is that step clear, right? So this is kind of a complicated step. Now from here, you can clearly see that the first three terms form a perfect square, right? So we could write this as 1 over b square. So these are perfect squares. So I could write this as 1 plus bx whole square. And we are left with these terms here, which is minus 2abx minus a square. Taking minus common, I could write this as 2abx plus a square, right? Divided by all this, which is a plus bx whole square. Now a plus bx whole square divided by a plus bx whole square gives me the first term 1, right? So what we get here is 1 over b square, and let me rewrite a plus bx whole square over a plus bx whole square minus. So now we are left with 2abx plus a square divided by a plus bx whole square. Clear? So we have got 1 now, and we have to now partial factor the other part. Correct? Now in this, we are looking for a term a plus bx. Okay, so but we have here 2b, right? So what we could do here is we could rewrite this as 1 over b square. So this is 1 for us, 1 minus. Now in this case, if I have to write a plus bx, we have bx, we could take 2a common, but we do not have 2a here, right? So what we can do here is that we can add and subtract 1a square, right? So we'll write this as 2abx plus, we have a square, we'll add and subtract a square. So we get 2a square, then we can take 2a common, right? And here we have a plus bx whole square. Is that clear to you? So this could now be written as 1 over b square, let me write equal to, I'm just squeezing it in since there's very less space here. Now we can take 2a common. We are combining these two terms, so that is 2a for us. Is that clear? That is 2a for us. So we can take 2a common. So we have minus here. So we have 2a common, and we are left with bx. And here we are left with a square. A common, a, right? So bx plus a and minus a square divided by a plus bx. We can rewrite this. Is that clear to you, right? Now, we'll finish it off by writing this as we have 1 minus. So we have two terms here, right? So bx plus a plus bx whole square. So that gives me 1. Okay, so we have here 2a in the numerator, right? This is the minus sign with us. So we have 2a, and then this is over a plus bx. Since one of these a plus bx cancels, right? And this minus and minus makes it plus. So we have a square divided by a plus bx whole square. Now when you compare with what is given to us, we see that b should be equal to a square, right? So on comparison, we know this is what b is, correct? So that means b is equals to a square. So answer C is the right option. Is that clear to you? Correct? So that is how you are going to solve this. So I hope the steps are absolutely clear. Go through it once again. The strategy is very neat. You're trying to complete the squares and get the result. You could of course do long division and otherwise. It takes much longer. This is a very neat method of writing into decomposed form of a rational function. I hope you understand and appreciate it. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.